Graphing proportional relationships. What is the slope of the line shown in the graph? So when we're looking for slope, the good news is I can use any point on the line, any 2 points, as long as I can clearly see where the points are. So a good example of that would be, I can clearly see where this point is, but this is not as clear, or this, right? They're kind of in between. I can clearly see where this point is. I can clearly see where this point is, right? So I'm going to use 2 of those points. Now, because this graph goes by halves, I'm going to use the very first point and the very last point, but you could use any 2 points, okay? So when you are trying to figure out slope, you want to look at the rise over the run. Rise means how far up or down I go. If I go up, it's positive. That would be a rise. If my rise is negative, that means that I actually had a fall, right? It means that it went down instead of going up. And always, always, always read your graphs from left to right. It makes sense. That's how we read everything, right? So graphs are no different. So if I start with this point and I want to look at how far either up or down and then to the right to get to this point, the way that I would describe it is that I would, if I were telling someone how to move from one to the other, I might say go down, and this is 2, and then go to the right, and this is 3, right? Now my rise in this case is negative because I'm going down 2. So my rise would be -2, and my run would be 3. That's it. The variable we use for slope is m, so I would say that my slope is -2 over 3. Does the graph correctly represent the proportional relationship y equals 1.5x? All right off the bat, I know that this graph is not proportional because it does not go through 0, 0. Remember, in order to be proportional, it has to go through 0, 0. But let's say it did, and we're still not sure if it's the right graph or not. So anytime you want to test to see if an equation matches a graph, you can pick a point from the graph. So I'm going to pick this point. This is the point 2, 0. Right? So it has an x value of 2 and a y value of 0. I'm going to put those values into the equation and see if it's true. So if I replace the y with 0 equals 1.5 times, and if I replace the x with 2, does that work? Does 0 equal 1.5 times 2? No. 1.5 times 2 is 3. So the points, when I plug those points in, even if I try this other point, 0, 3, let's just try it. So if I put 0 in for x and 3 in for y, I would have 3 equals 1.5 times 0. Again, does that work? No. Again, it doesn't work. So the points that are on the line don't fit in the equation. They don't give us true statements when we plug them in. So this graph does not correctly represent the proportional relationship y equals 1.5x. First of all, because it doesn't go through 0, 0. Secondly, because the points that are on this line don't make this equation true when I plug them in. Josh is a speed skater. In 10 minutes, he can complete 20 laps. What's his unit rate in laps per minute? Please, please remember, when you're asked to find a rate, or especially a unit rate, it gives you the order that you have to divide. If it's laps per minute, then you need to be doing laps divided by minutes. So let's do that. 20 laps divided by 10 minutes. 20 divided by 10 is 2. And then my unit would be laps per minute. Compare the data in the table and the equation. Which representation has the greatest slope? So remember, we talked about slope being rise over run. Here's another form of slope. Slope is also the change, I'm going to use this delta, which in math means change, the change in y over the change in x. So let's see how we use that. We can pick any 2 points and look at the change in y over the change in x. So let me start off easy. Let's say I decide to use these 2 points. Let's look at the change in y first. The y value went from 0 to 10. So that's a change of 10. The x value went from 0 to 2. So that's a change of 2. 10 divided by 2 is 5. So my slope is 5. I could have used any 2 points though, right? So let me show you an example with, let me just pick 2 different points. Let's say I want to use this point and this point. So from here to here, my change in y is 20. And my change in x from here to here is 4. 20 divided by 4, still 5. So any 2 points are fine. Just remember that when you're looking for the change that you go in the same order. If you're looking for the change from this one to this one, then you need to keep it from this one to this one. Don't switch the order around. So don't say, well, how does it change from here to here for the y? And then how does it change from this one to this one for the x? You can't do that. You need to keep that order the same when you're looking at the change. And then let's look at our equation. This value right here, we've learned about this value before. This was called, do you remember what this is called? The constant of variation, right? Or the constant of proportion, or the proportional constant. It has lots of names, but it is also slope because it describes how something is changing. So this value, which before we called it k, right? In this equation, it's also slope. So this equation has a slope, and slope, I'm just going to write slope instead of the variable for it. So slope is 5.5 in the equation. Slope is 5 in the table. So the equation has the larger slope. All right, I got one more for you. Actually, it's not so much a word problem as just another thing for us to look at for all the different names of slope, right? So it can be called rate of change, rise over run, it can describe a proportional relationship, which is when we looked at the constant of proportionality, right? Like we looked at on the last slide. Unit rate, constant rate of change, measure of change. All of those things describe slope. All right, so if you ever see any of that wording, it all means slope.